The complex type variables like array and not the unsigned integer, as we saw in the first example, are kind of hard to copy. The complex types, that is the types that do not fit into the 256 bits, in our case this array, and not the unsigned integer as we saw in the first example, are handled differently compared to the 256-bit data. That's because they are expensive to copy. Because they're expensive to copy, the EVM engineers had to think long and hard about it, and they came up with the following. In Solidity, whenever we deal with a complex type like this array, we always have to specify an additional annotation like storage or memory. And we have to tell Solidity where to store these things. You have to declare them whenever we are initiating them. The only time when you don't have to do this is outside the functions, because this is storage by default. This is storage by default, because that's the only place where you can store state variables. Everywhere else, we have to actually specify. We have to specify storage here, we have to specify memory here, and inside, if we are initiating, we also have to do that. Prior to version 0.5.0, the data locations could be omitted and would default to different location depending on the kind of variable, function type, etc. But now all complex types must be given this annotation and explicit data location. And this is better to understand the code to see what's going on. Before that, you actually had to know the rules, but depending on where you call it, it will default to something. So what kind of data locations are out there? We already know there is storage and memory. Is there more? So actually, there are 3 data locations. It's memory, storage, and call data. Memory is a data location whose lifetime is limited to an external function call. So this is temporary. When a function is done running, the data disappears. The storage, on the other hand, I cannot spell here. Storage, on the other hand, is a location where the state variables are stored. So these are permanent. And the lifetime of these things are limited to the lifetime of the contract itself. A good place where to use it would be, let's say you're writing an ERC20 token and you want to store how much a user owns. This is where you would store that value. And the third kind is a call data, which is a special data location that contains the function arguments. Call data is kind of non-modifiable, it is non-persistent, where only the function arguments are stored. This behaves mostly like memory, and it is required in the parameters of an external function. So if we go back to our code, this shows 1 and 2 side by side. So if we call it external, we would have to call it call data. We'll go over the reason why in a little bit, but that's how it is. Okay, we'll just change it back to storage. Awesome. Now let's go back to Remix. All right, so we already know that this actually changes this first value, 42. I can show you again, but that would be a waste of time. What if I change the storage type to memory type? What happens then? It's still an internal call. Let's see what happens. I'll try to compile this first. It's a warning, forget about that, and we'll deploy it. Got deployed, and if I look at the first index, the 0 index, I should get 1 because that's the default value. See the second index, I should get 2, and the index 2 should be 3, so that all works. Now if I hit run test, what should I see? When it was storage, it got changed to 42, but when it is memory, it did not. Something else happened. So when we did memory, it actually created a copy of the array in memory. So storage, so this is storage, the storage data location, and we explicitly said use memory data location. That there are 2 different spots in the system. So it created a copy in memory, and the memory got changed to 42. The first index got changed, but this remained the same. So we have to change it back to storage and then compile it and deploy it to see the old version of it, and it will change to 42. So why use storage versus memory and vice versa? The reason is storage is very expensive when it comes to gas usage. So you want to use memory whenever possible to keep the code gas efficient. On the other side, you want to use storage whenever you actually want to change the state variable. There is no way around it. So we should always know the difference between the two and change our contracts accordingly. Now, what happens if we change this function to external? When we change this function to external, I already told you that this memory will not work. We actually have to change this to call data type because that's what is expected. The reason the internal function needs to have all of the arguments in memory is because the internal functions may be called internally, which is the name of it, and that is a completely different process than external calls. Internal calls are executed via jumps in the code, and array arguments are passed internally by pointers to memory. Thus, when a compiler generates the code for an internal function, the function expects its arguments to be located in memory. On the other hand, when there is an external function like this, the compiler doesn't need to allow these internal calls. So the arguments can be read directly from call data, thus saving the step of copying the data. This is actually good for gas efficient code, and we should definitely do this. Moreover, let's try and run this function and see what happens. If this is external, we cannot call an external function from another function from the inside. So we can actually make this public. There's a very specific reason I'm doing this, and I'll explain as I look at the code. All right, so I want to bring your attention to the second error. It says the call data arrays are read-only. So that's another thing about call data. This call data, data location arrays, or anything that is stored in call data are actually immutable. You cannot change them. What you can do is you can copy them to another memory location, and then you can play with it. So you can actually say uint y memory equals x, and then you can change this underscore y to 42 and you can return y. If I try and compile this, okay, so we should do memory keyword first, y. Now if we compile this, you will see that error go away. We have another error that's different. We can actually so that is all I wanted to show. If you're gonna use call data, always copy this to a memory and then use it from inside. And it actually says that this can be pure. If we had memory here, we could not have used it as pure because it actually deals with some blockchain state. But because it's call data, it does not look inside memory and it can just be pure. All right, so that's it for this chapter. This was a big section and there was a lot to take in. Go get yourself a break. I need one.